Hello everyone, I am Manav, and in this video we are going to learn about how to assort the material, how to group them, how to group the different materials, and also about the matter. So let's begin with the matter. When I thought about this matter, I think that all those things mean everywhere, that everything here and there mean you can see me. You can see me. Why? It is due to of light, and the light is an energy, and our whole universe is made up of two things. Yes, of two things. First is our energy, potential energy, kinetic energy. I have already made a video on this, on the energies, on the different energies and their formulas. And in this video, we are going to learn about matter. So let's take a focus on the matter. Matter is everywhere. I am also made up of matter. Camera, your phone, everything is made up of matter. So matter, there are two properties of matter. Of any matter, if this chair is a matter, so there is two properties that this chair have. There's two properties that this chair has. First, that property is this chair has mass. I can take when I take it in my hand, I feel that a weight. There is a weight of it. That weight is also due to of mass. The matter that is present in this chair is also known as this mass. And duty of mass. If a thing has mass, so it also have weight. Yes, it have weight. I'm having two things. This both of the thing equal. Each thing has weight. And why they have weight? Why these both of the things have weight? First, they having matter mean mass in there. If this my hand, I carry my hand here. So my hand, there will be blood in our hand. Every person has blood, small or criterias. We can also say the RBC or WBC. These all plateaus, platelets, something plateaus. It's not. I'm not making you studying about the geography. We are going to learn about the chemistry. So everything, every matter that's present in my hand, and when I force act on it, there's a force that is acting on it. When the force act on it, we get our weight. And the one thing that you must remember is weight is not constant. If I am on the earth, my weight is 40 kg, but on the moon, my weight will be decreased. Why? Because my mass will be still remain constant. Although my mass will be constant, but our weight that is getting from the mass and the multiplication of the mass and our gravity is not constant. Yes, it's not. So if I go to the mass of the moon, my weight would be 20 kg, near about this. So if the gravity is acting less, mass is constant. If you go to moon, if you go to any other galaxy, your mass will be remain same, but your weight will be not, and your gravity. If I go to moon, let's suppose I have gone to the moon. I have landed on the moon. When I try to check my weight, if my weight on Earth is 20 79 kg. On the moon, it will be 1/6. And why I am saying only 1/6? When 1/6, this fraction. Why not 1/7? Why not 1/8? Why not 1/10? Because the force, the gravity that is on the earth is more 1/6 part. Mean the gravity that is on the moon is lesser than the earth. How much time? 1/6. So if I write 1/6 and multiply it with my mass, mean it's like a percentage. I'll get that percentage. I'm right. Or you can not multiply, and you will write 1/6 multiplied by your dash weight. So in this paragraph that I have taught you at a little bit time before, is tell us that our weight is not constant. Our weight is not constant, but our mass is constant. And the second criteria of the matter, if I'm sitting on this chair, as you can see, I'm sitting on this chair, so it is occupying some space. I'm sitting on like a sofa, so when I sit on it, there's a space that is empty. But when I sit on it, I take that space, and that thing that I have taken, that the space that is occupied by my body, or we can say that any chair that is placed here or on this chair that I'm sitting right now, it's occupying some space. I'm right. That there's a space. Mean if I try to stand here, if I try to take my wicket and place here, I cannot. Why cannot? Because our wicket is also a matter, and they will also take some space. But that space is already booked by the chair. So this thing tells us that every matter has its own volume. This volume, the space occupied by any object, is known as volume. And if I take a box like this, a cube box is a 3D shape. I can take some things, any material, and placed on it, or on it, in it. Mean there are two, mean like a box. It's like a box, and there is some like a gate. I place it in. I place that thing. I'll place the thing, the matter. They will occupy some space. So there, the space that is in that object is equals to it space that is occupying on the floor. So let's move on to the three state of the matter. So while we wait, let's begin. Three state of matter. You must have seen water in the form of ice. That form of ice is a solid. And when the water that you are drinking is in liquid form. And in the winter, when you boil the water for drinking, some of the water evaporate. And when you take steamer, while in the period of the corona, right now also, we are taking streams. We take a blanket and we take an utensil where is a very hot and hot water. And when we open it, there is a gas that is coming out. And this gas is a gas form that is also matter. Oxygen, carbon dioxide, nitrogen, and all other gases. Air, we take air, is occupying some space. Air is here, everywhere. Okay. So let's start with the solid. In the solid, if you go to the in detail of the solid, what you will found with the, if you take a microscope and doing like this, you will see that the particles of that object that is in the solid form is very bonded. They are very packed to each other. The small particle from which our matter is made up is they're very tightly to each other. I mean, they're bonded. You might have heard about the ionic bond and chemical bonding. I don't know what is this chemical and ionic bond, but bond mean we take it at a place, mean tightly packing something like this. They're tightly packed with each other. Why? Because the force of attraction between them is too much. I'm right. So this are packed, bonded, these gases, this force. I have used this word force. Which force I'm talking about? This is the force that is of an atom. Atom has its own force. They attract when an object is solid in the form of solid. Particles are too tightly bonded by each other with the help of atomic force. But teacher has told this. I don't know that there's also gas. Not a gas. A force that attracts them. So let's move on to the liquid. One day, I having ice in the Antarctica. I go to the desert. I seen that the water started. The ice get melted up. Why? Because when the heat is thrown or any placed near a solid, so the attraction, the force that atom has, the bonded force get lose. It get damage. It get a damage. So by heating, there is a damage to the force, and the particles start moving here and here, here and here, here and here like this. When they started moving, we see that liquid can go here and here. A liquid that if I have a liquid in my hand, the space that it will go at that point. If I having water, so I will do like this. Water the particles of the water get that area to move. They started moving at that area, in that area. Yes, they will. And in the gas, am I having some water and I am going to desert? And what happened? By mistake, I have poured it into the boiling bowl. And it evaporates. Yes, it started evaporate. And when it evaporates, there is much and much heat produced at that time. Due to that, there is a little bit force that is remain. It get also explode. And after that, our gas is revolving here and here and here and here. And now we can feel the gas. We can feel the hydrogen. We can feel the air. So I hope, friends, you understand our today's topic about the matter. And thank you, friends.